Hello and welcome to this lecture where we'll go into group by in the coding part. So start with going into this page here and download the dataset. The reference link is in the course lecture note. So after this, we move on to Visual Studio Code. And in Visual Studio Code, I have created an SQL folder and a data folder. I placed this file, the CSV file, into the data folder. And I have created a script called ingestfood.sql. And in this one, it's the ordinary, so create table if not exist, food as select star from, read CSV auto, and this path, note this path, I start with data/food search google.csv. And this has to do with where you are in the terminal, right? So where are you in, which is your working directory? So my plan is to be in this folder, 08 grouping data. So basically 08 grouping data, and then I can do like this. I will create DuckDB. Let me see what it's called. DuckDB Google searches.duckdb. And I won't create it directly here. Instead, I will put it into the data folder. So this means that I go into the data folder, and inside there, I will create this database Google searches.duckdb. Okay. So now I have this database, and what I will do is .read. So I will read an SQL file. So I will go into the SQL folder. Note that I'm right now in the root folder. So then I need to go into the SQL folder and go into ingestfood.sql. Run this one. And it seemed to work. We can see that we have DuckDB, we have DuckDB.wall here, so write ahead log. So if I just do this, then we can see here is the table, right? It's inside of the main schema. So if then I can do select star from main dot, what is it called? I call it food. So here, this is the data here. Great. So I will jump out here. So Control D for Mac and Control C for Windows. And I will move on to dbeaver. So here in dbeaver, let's connect to the database. So start with opening this file from opening this folder. Let's see. It's not here, it's in SQL course demo. Oh, not this one, not course demo, instead course demo 08 grouping data, like here. And then I finish this one. And I will open the connections, open a new connection here. And let me do this as well. I'll choose DuckDB. DuckDB, next. And the path to this data, Google searches.duckdb. Finish. And double click on this one. So now we're set and up to go. So in our SQL, let's create an EDA first. So EDA food.sql. So EDA means exploratory data analysis. So this is what I will do first to understand the data set. before we go into any grouping. So select star from main.food, run this one, and here you can see we're up to go. So we can see the database, we can see the table. We see ID, Google topic, week ID, and value. And week ID seem to be, the weeks, basically, from 2004. So let's continue searching more. Select distinct ID from main.food. And we can see here are all the distinct foods. So if I scroll down, we can actually, we don't need to manually count it. We can use SQL to count it. So count, like this, and we see 201. I will do also like this. So Control Shift F to auto format it. Select count star as number rows from main.food. Okay, we see there's a lot of rows, so we see that a lot of all the foods, we see that they are repeating itself, right? Because we had 201 distinct food IDs, and we have 135,000 rows in total. So basically that means that one food can be searched for several times in this data set. So let's do some more. We can describe the table. So describe main.food. And we can see here, okay, first one varchar, second varchar, third one is varchar, and the fourth one is big int. Okay, great. Let's continue. Let's do some filtering here. So select star from main.food where week ID, we can do like between 2004 and 2006, just to test it out, see if we can filter, and it seems to work. We have 2004, 04, 05, 06, etc. So the first the first 3 weeks here in the data set, no, not the first 4 weeks, from week 4 to week 6, basically in 2004. And if we scroll down here, we see we are still in 2004. So it works to do the filtering like this. Okay, great. So this was some simple EDA. I encourage you to do more EDA. So I'll write here, do more EDA to understand the data set. So, but I won't do it here. Instead, we'll go into some group by. So let's create another script here. Remember, we have to mark it and create a new script. And I have, you can see there is a, here you can see the hotkey. Actually, I've changed the hotkey so that for me it's Control N, but I forgot what the default was, but I have changed it. So you can do it also if you want. And also F1, F2 in order to change the name. Otherwise you can right click and change it. That also works. So let's do some group by. So select star from main.food, run this one, and we can see we have a lot of foods that are repeating itself, right? So what if we want to pick out, for example, select from main.food, and what I want to select on? Well, I want to select on food, or actually it's called ID, right? So actually we want to transform the data first. So let's do some transformations here so that we get better rows. So I create a new script so we get better names again. So transformations.sql. So when you do data transformations, so remember it's usually when you have a data pipeline you have ELT or ETL. So T is the transformation part, and in the transformation part you do things with the data set in order to make it cleaner, to transform it into a certain way, into a certain format that is suitable for analytics. So if we select star from main.food, we can do like this. We can change the ID to food. So copy this part. Select ID as food, and then you can see that it becomes food here. I want to select the week ID as week, and we can see the week here instead of week ID because I wanted to rename it. And for the year, this is quite special here. So if we see in the year, it's a string in varchar. And I only want to pick out the first 4, right? So that can be done in 2 ways. In SQL, in normal, you do like this: substring week comma 1,4. Yes. Here, and you do like this, and you see that it works. So it picks out the first 4. This could also be done like this. So if I copy this one and paste it here, instead of using substring, I could do, but this is specific for DuckDB. I could do like this: :4, and you can see it's the same results. So this is slicing, similar to in Python. So DuckDB has slicing implemented. However, most of the databases don't have it. But we will come back to slicing later on as well in DuckDB in the string lecture. So right now I'll use the substring. And I will choose value as number searches. So I just changed the name on this one as well. Okay, we can see number searches here. And now, now we just selected this, so it doesn't save. So in order for it to save, we can do like this: create a new table, create table if not exists, clean food as like this. Oh. So basically what this means is that we create a new table called clean food, and then we do the select statement, and so we save it there. So I run this one and we can see that it has updated, and let's do some select star from main.clean food. Like this, and we can see here we have changed food, week, year, and number searches, right? And also I skipped I removed the Google topic column, right? So if we check the normal one, the raw data set, we see that we have the Google topic. I don't care for that, so I removed that one. So that concludes the transformations. So basically now if we move back here, we can do select star from main.clean food. So this is what we have now. Remove this F as well. This is an alias here. Main dot cleaned food. So now we can use the food here instead of ID, right? Because we aliased it. And here, let's do some more thing. We want to group by. We want to group by the food. We want to group by the food. And if we run this one, we just see the food, right? Because we have grouped by them. So 201, that is what we expected since the count was 201. So basically, when you group by, you squash them together, and you pick one. You can pick one aggregate function for a certain column, so that it calculates some aggregation. So, for example, I want to have total number of searches. So I do sum of number searches as total searches. Like this, and you can see here here's the total number of searches for each of the food. Okay, yes, great. So pizza has been searched for 35,000 times, Easter egg 2,800 times, etc. Okay, and can we do a little bit better? Well, we could actually order this. So order by. We want to order by total searches, and let's do a limit as well, limit 10. So this is 10 favorite food that has been searched, or actually not favorite food, this is least favorite, because here we see it's ascending order. So let's do it in descending order. Descending order. Oh, limit 10, actually order by in descending order. So, great. And you can see, okay, sushi was searched most, etc. And beer comes second. Okay, and yeah, beer counts as food, I guess. So, let's continue do some more things. Let's copy this one again. Let's copy this one. And we pick, instead of grouping by food, we can group by year. And we can have order by total searches. Yeah, that is good. Some total searches, we could have, instead of food, we have year here. Main clean food. Yeah, that's true. Correct. And it may not be surprising, but I guess that people use Google more the further we come. So from, you see 2016, it's the most one, and then it's decreasing, right? For each, so Google becomes more and more popular, I guess, and people search more and more on food, or actually more searches in general, and then in general the food searches also increases, I guess. So let's see how many years there are. Maybe we don't know if there's 2017. Maybe 2017 was a year where no one searched for food. That's why it's not here, or very low. So let's check that out also. So select distinct year from main.food, and we can see it doesn't work. Main.clean food, it's called, like this, and it seems to work. And you can see the distinct years. We have 2000. We don't have 2017, right? So 2016 is the newest one. Let's do, and also you can see the ordering might be weird, and that's if I run it again, the ordering changes, and it's not surprising, as we haven't ordered by it, and the database just chooses based on what is most optimal for giving back this this query. So that's why it changes. So if you want to have a fixed, you want the rows to be fixed, and then you do an ordering, right? So select year, comma, sum of number searches. Number searches as total searches. So we do this again. From main dot, actually I could have copied this. Clean food, group by year. Okay, so this is actually the same as before. So this is no surprise here. We haven't ordered by, but I want to show you a filtering here. So instead of using where, when you're doing group by, you filter the aggregates using having. So having class. So having total searches larger than 300k, for example, 1, 2, 3, like this, and we get all this, and we could order by this. Order by total searches on this one. Okay, and it's in ascending order, so let's do descending order as well, like this. Perfect. And now you can see, these are the, now we have filtered on all the searches which is higher than 300,000. So that you could do as well. So I will disconnect this one. And going back to Visual Studio Code, and we can see that we have DuckDB here. We can do, yeah, exactly, DuckDB data Google searches.duckdb, and we can do desk, and we can see we have Google searches, two of them. We have clean food and food. So it has saved. So select star from clean food. And we can see that, yes, food, week, year, number searches. It works. And I'll do Control D to exit this one. And here you, since you are in a repository, you should push it, commit push it, but I don't. With this, you have learned grouping of data, you have learned exploratory data analysis, you have learned how to do simple transformations. So this is really, really useful. We'll come back to it a lot later. So thank you for watching this video. See you. Bye.